sorry, record on this computer. First and foremost, we need to talk about assets, which is, so a lot of you have decided to write a game. That is awesome. And then I've also suggested to a lot of you that you should use, you know, like a graphical framework. That is also awesome. But art is hard. You know, you know, we look a criticism of many pieces of modern art is my child could do that, but your child didn't, and this person did. It turns out actually doing art, making statements, making things that people feel something is really difficult. And so if you want to take a crack at it, great. But if you don't want to take a crack at it and you want to, you know, get something down as early as possible, and you don't want to use, and you don't want your game to just simply be squares and circles, the very basic shapes, you probably want to use some assets, some sprites. So what is a sprite? Well, it's a type of fairy, I believe, but also a drink. But no, a sprite in computing is essentially a two-dimensional image, typically used in video games. It's typically something we refer to that only occurs in video games. Often we use something called a sprite sheet. So Mario sprite sheet that simply has like all of the useful kind of images that of a character that we want, all nice and drawn out. Okay, yeah, I don't want that. No. So there we go. Open image in new tab. Why not? So for instance, hey, look at this horribly zoomed in picture of Mario in of Mario from Super Mario World. These are all various sprites. And crafting each of these, because again, this is an image crafted from pixels, takes time. Time that you may not feel like you have. If you want to do that, it's awesome to learn it, and the more you do it, like any other skill, the faster you'll get at it. But you might feel, no, I don't have time for that. So can I just simply reach out to my favorite game and grab, you know, whatever they use from it? Can I use Mario sprites in my stuff, in my game? And the answer is legally no. Not really. Nintendo especially is very vigorously protective about their copyright law. They come down on fan projects hard with a disproportionate sense of retribution. They are very protective of their intellectual property. In general, you can't use other stuff without their permission. Fortunately, a lot of people give you permission to use use their stuff if you know where to look. For a lot of stuff, it is the Creative Commons license that is possibly the best thing to use. I recommend two things that fall under two categories. Creative Commons, which is a license specifically set up for doing works like this, pieces of music, pieces of art, pieces of literature. So the idea here is that there are a few different kinds of licenses, and they all come down to different kinds of licenses that are available, depending on what the person who, so say you find somebody else's sprites into some of their Creative Commons license, they will typically have some kind of license for you to use it. The most basic one and the easiest one is CC BY, Creative Commons BY, meaning that they just want you to simply mention them in the credits, essentially. Give attribute, as long as the person is credited for doing the work, then that's fine. I mean, that makes sense. Like, you cite your work in academia, so that makes sense. Like with these kind of projects, you'd cite that. Some are a bit different. For instance, over here, this says, hey, this one is where we got to start being careful though. CC BY share alike. Okay. The idea here is that if you can use the material, and if you build upon that material or remix or adapt it, so you take their art, redo their art, that art also has to be CC by attribution share alike. In other words, if you use something under this, you also have to do this. Here's a more common one might be something like this, no commercial. In other words, for something like a student project, because you're not selling it, share similar to this, non-adaptive, non-derivative, meaning you can't change, they made a picture, you can't change the picture, please, but you can use it however you want. In other words, if somebody made a pixel art version of the Mona Lisa, you can't take their pixel art version of the Mona Lisa, draw a mustache on it, and put it in your game. You have to keep their pixel art Mona Lisa untouched. But what about the Mona Lisa? The last I checked, Leonardo da Vinci is, long dead. His stuff falls into what's called the public domain. Now, what the public domain is differs from country to country. In the US, it's dictated by Disney, essentially. No, Mickey Mouse. Yeah, same thing, I jest though. But it's all about intellectual property, simply put. So some works are not covered by copyright laws in the public domain. But the idea here is that these are works that basically the copyright has expired. Okay. So for instance, Shakespeare, Beethoven, Da Vinci, all simply are in the public domain simply because they have existed since before copyright existed. Some things are excluded from copyright, include like formulas, cooking recipes. By the way, this is why you see, like, when you see a cooking recipe online, this is why it has a story about how it's their grandmother's favorite recipe, and whenever she eats this feeling, these are the feelings, or this is something I learned while I was, on vacation or something, and I got some advice from someone on how to do this, and now I do this by telling a story. That story is now copyrightable. So, it's theirs, at least from what I understand. I could be completely wrong about this. Other works actively, and all computer software before 1974, other works actively dedicated by their authors to the public domain. Examples include reference implementations of cryptographic algorithms and stuff. The public domain is, the idea here is that it is things that is created that there is no copyright for. This is why you see so many different movies with Dracula, so many different incarnations of Dracula, because he's a public domain character. Bram Stoker is long gone, and the historical figure he's based on is even longer goner. So things like that are perfectly okay. In other words, just try your best not to run afoul of copyright law. Now, with regards to how you use copyright law on your end, if you're going into software development, then that is something you'll eventually need to know. So if you remember nothing else from this lecture, please remember this. If you're going to grab some code from the internet, okay, doesn't matter what the license is and whether or not you're sure about that. Your company probably has a lawyer on payroll. Run it by that lawyer first, okay? It will save you a lot of headache. My friend who went to work for Google said about like 1.5 days worth of his orientation in Google was basically lawyers coming in and screaming them into submission about grabbing stuff online. Not screaming, but you get the point. It is copyright law is very important with regards to software. In fact, there's a large portion of the internet that relies on the fact that a lot of stuff uses what they refer to as a copyleft license, meaning that they make it so that anybody can use their work. Most of your if you're using an Android phone, you're using something based off the Linux kernel, which is open source software. A lot of websites run off of open source software. I think programming languages are by definition open source. In general, choose a license for your own personal projects. It's a very good way to do it. Generally, there are the most basic and most permissive, basically saying, I don't care about this, anybody can use this. Don't come yell at me if it breaks anything, though, is the MIT license, which says you can use it, you can distribute it, you can even sell it, you can package it up and sell it yourself. Just don't come crying to me if something goes wrong with the code. You know, you're responsible for that. Similarly, there's community licenses. GPL, the GNU public which stands for GNU's not Unix. The GNU public license is one of their is, as I understand it, and I am not a lawyer. Okay, so take whatever I say with a grain of salt. I am not a lawyer and I'm not qualified to make these statements, but that's not going to stop me anyway. So please, from what I understand, it is a viral license, meaning that anything you use, if you write something in the GPL using the GNU public license, that means that somebody else who uses your code must also write their own program using the GPL. As far as I understand it, there's probably some subtlety in there that I've overlooked. So again, consult with an actual person who spent years of their life studying this stuff. This has cost companies quite a bit of money by not doing this. They also have a LGPL, which is a lesser GNU public license, which does not have that viral clause in it. And again, this is as far as I understand, but there's a ton of licenses for there. In general, I would just simply choose a license out of habit. In fact, if you create when we go to GitHub and we were skipping by creating a repository, right, while you were busy frantically setting it up, it had a choose your license over here that you probably ignored. And then you can go and select one of the licenses and it will automatically create this. Okay, let's go with Silver Giggle just to show this. Add a README file. And here's, actually, I'm going to go ahead and grab a GNU public license. Let's see, is that GNU Afro? I don't know what that is. Yeah, whatever. I'll just use this. Oh, general public license. There we go. And create repository. And it automatically populates it with a license file, which it automatically reads and displays this, which is hey, pretty cool. Here's the license file, and you can even just copy that and drop that into your own repository if you want to follow this license. If you want to put on the most rudimentary protection of copyright or copyleft on your work, at the very least being able to say you did this, use a license. Okay. But the end of the story is that basically for a lot of video games, you can look for stuff like Creative Commons sprites. Here, itch.io, top game assets with assets under the Creative Commons license, right? And tons of things over here where you can just download stuff. Fantasy Hex Tiles. Oh my God, if you're doing a strategy game, that makes it a lot easier to do, right? Free packages, 16 by 16 refers to the number of pixels, backgrounds. This kind of stuff is made by people and it's, essentially given away for free because they want people to use their work and see their work. Now, that being said, this isn't the same as working for exposure, which never worked for exposure. Don't. It's bad. A lot of these are passion projects and released because either they want to help people developing games, or these are just simply like lesser or toned down versions of their actual stuff that they sell, like a free demo. A lot of companies do that. Like especially with music software, a lot of companies will, a lot of the higher end music companies will basically make, free software so that they'll get you into their ecosystem. It's part of the reason why Microsoft is so keen on handing out copies of Word for students, so they can get you into their ecosystem. There's nothing nefarious about them. It makes sense. And when you're used to that, you'd rather use Word rather than using one of the open source alternatives, which there are. Open source software is what makes the world go round. And a lot of the internet relies off of the fact that open source software is used. Let's see. I haven't looked at the stats for web browsers, but not web browsers, but websites and web servers. But does anybody know just off the top of their head what percentage of web servers use Linux? Here we go. What percentage of webs? Oh, there we go. About 96.3% using open source software. Open source software is big, and a lot of companies do contribute to open source software. Again, Microsoft has been really good about open source stuff recently. They make one of my favorite editors, which is VS Code. It uses an open source. It's built. They use an open source engine, and then they add some extra stuff on top of it. But the underlying stuff is open source that you can use, and it does get used. It's fantastic. And it's free. That's another kind of thing. And that idea of free does have two connotations in the open source lexicon. Just be aware. Free as in free pizza, and free as in freedom, as in you have the freedom to do what you want with it. So just be aware of that. But let's see, open source, but this stuff is great. But it's also got like a weird side. A lot of stuff has, so for instance, a lot of stuff relies on open source stuff. So if somebody makes a change, that change it's like, you're building the internet's basically just a bunch, it's like a giant Jenga tower, or not so much a Jenga tower, it's like a Jenga jungle. And you never know when removing one block will cause a cascade of things to collapse. One very famous example of this happened in 2016. In fact, a lot of what we're going to be talking about happened in 2016 and 2015. So where NPM, where a package got removed, a developer, so in this case, what happened was a developer was asked by another company to hand over the name for one of his packages to a company called Kik. And he wrote, and NPM side with the company. Okay, there's reasons, and everybody has a side on this. Nasty language was used, or I guess heated language might be more used. But at the end of that was that NPM side with the company, and as a result, the user or developer, Azar Kochulu, I believe, he decided to remove all of his packages, including one called LeftPad, which was weird, which is a very kind of, computer science, like basic level kind of early computer science assignment kind of level of code, which does stuff like this. It adds, here we have foo, we take in, and it takes in the argument 5. So it wants to make this 5 characters long by padding it with either spaces or 0. Right? So over here, we took in foo and 5, and it adds 2 spaces in front of this. 6 doesn't do anything. It doesn't change it. It takes in 1. It should be 2 digits, and you want to pad it with 0s in front of it. Great. It makes it 2 characters long and adds 0s to the left of it. That takes in 17, 5, adds 0s to the left of it. So now it makes that number 17 5 digits long, 5 characters long. It's very straightforward. It takes almost no code whatsoever to do. I think it's like 15. It is not that many. The comments are longer, to be honest, over here as to what it does. Okay, but he wrote this, and a lot of people, rather than coding up their own version of this, which they should have been able to do, just decided to use this to write their own package, because hey, it's always going to be there. And then some other people may use that to write other packages, which wrote other packages, which wrote other packages like React, which powers stuff like Facebook and developed by Facebook. And then so when NPM when he withdrew all of his packages, that broke all the packages that relied on LeftPad, which broke all the packages that relied on that, which broke things like Facebook, like their entire website. It says that they were down for about 2.5 hours. So yeah, again, one kind of the internet is built on the assumption that things are going to break, and in fact, they are breaking all the time. If you look up TCP/IP, the entire and the way that works, the way that computers talk to each other, as you will if you take a networking class, you'll learn that things break all the time. Okay, we rely on Murphy's Law. Whatever can go wrong will go wrong. And so, but that's not always, but we don't always remember it when we're developing things for interpersonal disputes. So just be aware of that. A lot of things to be aware of. So now to the actual content of our lecture. We get to discuss Florida Man. Or exactly, we're going to discuss why Florida Man is a thing. So for those of you, so there's a number of you who are not native to the US, so you might not understand what I say, what I mean when I say Florida Man, although it may be an international phenomena. So would anyone like to explain for the class, what is Florida Man? Yes.
Essentially, there are a lot of headlines that come up that say Florida Man, and then following that is just
some wild story.
Something like Florida Man, he's claiming taco.
Yeah, there's a lot of stories about Florida Man does something wild, commit some really wacky crime or something, and they just always seem to be Florida Man. It's never Wisconsin Man or California Man. But it's always Florida Man. And I'm not making this up. This is actually a phenomena that happens. You can check, I mean, here you go. Florida Man, Florida Man, Florida Man, Florida Man. Internet meme first popularized in 2013. So why does it happen? So why is this a thing? Well, it has to do with the fact that Florida has some very interesting sunshine laws. So it has some very interesting laws related to their public records. The Miami New Times, which is again a Florida-based newspaper, so I guess they would kind of know. They say that the Freedom of Information laws in Florida make it easier for journalists to obtain information about arrests from police than in other states, and that's responsible for a large reason. So, in other words, you need, I mean, in today's day and age, you need people to come to your website to read your stuff so they can be exposed to ads so you can continue to pay for the real journalism that goes on. This is a model that was really done successfully by BuzzFeed, where their listicles and other kind of clickbaity articles went on to really fund their extremely good journalistic side of things, which then got bought out by a separate company. But that is what a lot of websites do. That is kind of the recipe for success. Make the stuff that people read and use that to fund the boring but important stuff for media. It's not a perfect solution, but it works. And it's a very hard kind of, and that's an entire kind of discussion for another class, that this isn't this one, as to what is the appropriate way to fund journalism. But regardless, there's other reasons. The breadth of the simply wide disparity of population and climate, and and the like make things just a bit crazier. So, but why am I bringing this up in this class? It has to do with this freedom of information laws. The idea here is that it is the policy of any state, county, municipal record shall be at all times open for personal inspection by any person. Documents, letters, sound recordings, data processing software, other materials. 1995. Data processing software. 1995. Pretty early on in terms of figuring out legislation around that kind of stuff. The law defines agency as any state, county, district, authority, municipal officer. Ooh, very broad. So it's very, very broad. There's certain exemptions, such as personal information, you know, like social security numbers. But long story short, it is very, very open. Now, the reason I bring this up is because today we're going to learn about regular expressions. And to understand why I'm going to be talking about the story I'm going to be talking about, there's a couple things I need to tell you. First off, Florida has a very long history of releasing of making this kind of data available. Okay. Second is that we're going to be talking about a political figure. It's not the one you're thinking of if I'm talking about Florida, but I'm not going to lie and pretend that I'm a completely apolitical animal. I am in fact very political, but that's not relevant to this class. The reason I'm going to be talking about this particular individual is because he had the most relevant example and the most recent example of a problem that can be solved using regular expressions. When another government official performs the same mistake, I will update this example to reflect that. I don't share my political opinions with my students. That's not appropriate for this class, but I'm not going to pretend I don't have them. Okay. So today we're going to be talking about the 2016 election and specifically the candidate Jeb Bush, who was the governor of Florida from 1999 to 2007. He ran an unsuccessful campaign for the Republican primary in the 2016 season. And it was rather unremarkable because there was a lot of drama that was going on during the 2016, to put it as mildly as I could possibly put it. Now, with regards to that, one particular piece of drama that got buried under that was actually an email scandal, or email, I should say, mishap. Because that got overshadowed by other stuff relating to emails, as you may well remember. So this was, oh no, this is not about buying a website domain. This is in fact about this. So Jeb Bush, emails. So let's see. So there we go. Jeb Bush releases thousands of email. Florida releases thousands of email from former Governor Jeb Bush. So what happened here is that he basically released a bunch of emails from his 8 years of governor. Now, again, I want to point out, to his credit, let's look at when he was governor. Again, 1999 to 2007. That was an extremely early adoption of email by a government official. Okay, I mean, that was fairly early in terms of like government official doing government business via email. Okay, which is great because that makes it extremely relevant. You do have to reach out to your government officials occasionally in this manner to resolve certain things that cannot be solved any other way. The most notable example I can think of is that when you need to not be dead anymore. Occasionally a person accidentally gets declared dead by the state, and you can imagine this makes it difficult because dead people can't vote, dead people can't get paid, and they can't get licensing information, and of course the normal agencies can't fix this because you're dead. They can't fix that. Generally the easiest way to get through this is to just cut through that red tape and get to somebody in a higher position of power, such as your state representative or your congressional representative or senators or your governor. There are a number of kind of ways that reaching out to a higher authority or a public servant can actually cut through a lot of red tape. Okay. So let's see if I can't find Jeb Bush releases emails, personal information. Now, that being said, yeah, let's go with the Verge's article because this is what it did in fact happen, which is Jeb Bush dumps emails, including social security numbers of Florida residents online. That is the issue, not necessarily the issue of, so that's the scandal there or the mishap there. Okay. And now, again, this is not, done with any malicious intent. Okay. But like, again, there was a culture in Florida of let's release this information to the public. Let's go ahead and make it available. Okay. Some are funny, some are serious, some I wrote in frustration. But what happened is that these weren't parsed. So here's some emails that have been there with the personal information that has been parsed. Okay. To Jeb Bush, dear Governor Jeb Bush, RE blank, social security number blank. Now, again, for those of you who are not American citizens or didn't, and thus don't know the significance of the social security number, a social security number is a de facto, but not de jure, national identification number. Was never meant to be your national ID. In fact, a lot of Americans vociferously are against having a form of national ID, state ID, yeah, but national, no. Which is different than a passport, I should point out, okay? But regardless, that social security number is one of those kind of pieces of personal information that can be used in terms of impersonating another person. So that's kind of an issue. So if this kind of gets dumped on the internet, well, they've got their name here and their email, and here's to inform you that employment of a person that looks like he has been had been basically in prison at some point and was on parole and was and an email that was trying to attest to the character of a person that they was under employment, which is great, but this information does not need to be online, which was an issue. Another email on behalf of a healthcare representative. This is all about, again, what I was talking about. This is an email trying to get a kid into surgery, get it paid for by insurance. This is trying to use the governor or get the governor to help cut through a lot of bureaucratic red tape going on. Okay. Again, social security number, Humana ID number, which is your, medical insurance information. Okay. So as they point out, and as they point out in the article here, Florida's freedom of information laws are very broad. And he points out that in the signature of many of his responses, Florida has very broad public records law. Your communication therefore may be subject to public disclosure, but social security numbers in particular, they say, are protected. They are confidential and exempt, and other stuff, of course, should be exempt. This is more of an accident than a kind of deliberate kind of we don't care thing. It was just kind of a, oh yeah, that was something we forgot. And it got pulled pretty quickly. Most of the same emails that were released today had already been available since December 2014. Wasn't a big deal then and was kind of a deal now, but then they were pulled. So how do you deal with this kind of stuff? I mean, you want to release like a bunch of documents, but there's a ton of personal information on there, right? But let's look at one in particular, the social security number, okay? The social security number is one in particular, and now it is the time to say the part that gets students interested. For every final exam I have given in this class, one of the big questions that you can potentially take has always been of this format. Given a file, write a program that finds all the social security numbers and in the file and creates a new file, which is the exact same file, but with the social security numbers removed. In other words, write a program that read the file, strips out all the social security numbers. It isn't always social security numbers. Sometimes it's telephone numbers. Sometimes it is made up healthcare ID numbers. Sometimes it is email addresses. These are all different examples of it, but it's always of that format. Given a file, read the file, get and censor out the information that really shouldn't be released to the public because that's personally identifiable information, and we don't want to be sued, please. So you can see that this is a real kind of task you might actually have to use, and going through this kind of stuff is annoying manually. I mean, you can't really just Control F a social security number, except you can if you know how to do it, if you know regular expressions. Okay, so let's talk about regular expressions now. I know that was a big introduction to this, but honestly, if I just simply go on about the normal introduction about regular expressions, then you're going to just kind of be be bored about it, because the normal idea of regular expressions were formalized by mathematician Stephen Kleene, for whom the Kleene star in regular expressions is named after. He created the concept of regular languages, which were the linguistic equivalent of discrete finite automata. And you know it's horrible to look at because it's got all the Greek in it. And you know that deterministic finite automata, even though they are nothing more than flowcharts, are also terrifying because they use even more Greek in their to define their stuff. Your guys kind of just look at that and glaze over. They don't just use like the familiar Greek; they use like the weird Greek in there too. But the idea here is that if you've got a program no more complicated than a flowchart, you can encapsulate it in what's called a discrete finite automata, basically saying we go from one state when we receive this response, and we transition away from that state when we receive another response. And we have a beginning state and an end state. Okay. This can be formalized linguistically in something called regular expressions. So here is a pretty good example. There's a regular expression here from Genesis, and a document, specifically the first lines of Genesis. Here we have the regular expression that's being used. H bracket A-E-I-O-U plus. What does this do? It looks for any vowel. Sorry, it looks for the letter H followed by any number of vowels. So note what it looked for. It found the he's in the, but also the HEA in heaven and the HOU in out, in without. So that's a pretty good example, I think. But the idea here is that regular expressions, also called regex or regex, I don't know what the proper pronunciation is, these are used for pattern matching. Basically, if you want to try to match some expression. If there are limits to this power, basically, if you're trying to if you need to use something that requires a loop of some kind to count stuff, then it's kind of going to fail. If it requires memory, it's going to regular expressions aren't the tool. The classic example of where regular expressions fail is bracket matching. In other words, or parentheses matching. In other words, you're trying to make sure, like, for instance, in your editor, your editor will sometimes look at the, you'll hover over a bracket or a parentheses or a curly brace, and it will highlight the closing one or the opening one that goes along with it. That kind of thing you can't use regular expressions for. They kind of break when trying to make sure that that you've got the right brackets in the right orders. Okay. But failing that, for looking for sequences of stuff that follow the same format, like social security numbers or basic email addresses. because email addresses are so weird. So weird. The formats that you're allowed to have for them are very weird. It's incredible. But for this kind of stuff, regular expressions are great. So the idea here, so I'm going to do a lot of this testing on a website called regexer before I move on to showing you how to use it in Python tomorrow. Not tomorrow, but Thursday. Okay. So, and this will probably be on the third exam, which will be in a few weeks. Now, with regards to the third exam, I think honestly, because of the way that we're kind of coming to the end of the semester and we've all got a lot to study for, I'm going to make the third exam and the last assignment essentially optional, kind of, sort of. The idea here is that the exams are now 3 drop 1 as opposed to just 3 exams, meaning that each exam basically has a weight of 15 points. Therefore, if you're happy with your exam grade, you can skip out on exam 3, no penalty. Make sense? And if you want to try to score higher, well, there's no risk of doing any worse, because if you do worse, it'll drop, that'll be dropped. Make sense to everybody? Does this make sense or no? I am switching, instead of doing 3 exams, each worth 10% of your grade and a final exam, okay, we are doing 3 exams, drop 1. Thus, 2 exams will be worth 15% of your grade apiece, as opposed to 3 for 15. Sorry, 3 at 10 each. There's also the final exam, but that's its own different thing. Okay. And the reason I'm trying to do this is just to make it less stressful for everybody. Similar with the regular expression assignment, that assignment is going to be an optional assignment. Essentially, I will move from dropping 1 assignment to dropping 2 assignments, and then I'm adding this additional regular expressions assignment. So you don't have to do it if you don't want to, but if you missed an assignment or you just couldn't figure out one, you can instead do the regular expression assignment. Make sense to everybody? Okay. So in other words, this should be a lot less stressful. When will exam 2 be graded? That is a great question. I told your TAs on April 5th to start grading it. I plan on grading the group exams tonight. So because last week Wednesday evening was Passover, Thursday evening was also Passover, and Friday during the day was Passover, and Friday evening was Shabbat, and Saturday during the day was Shabbat. So it was a very long amount of time where I just wasn't really working too much. So I hadn't really gotten a chance to work on that. The lecture videos, they should be posted. I've been posting them regularly, I thought. This one I should get up fairly soon. Now, with regards to this, let's go back to regular expressions down here. Okay. Let's go ahead and write a few clauses here. This is where we put our example documents. So let's go with hello, Mr. Enter Governors. Is it whatever. The person writing this probably is going to misspell it anyway. Name here. I am let's see. Let's go with Alice Adams for AA. And I SSN 123-45-6789. And if that's your social security number and your name, I'm so sorry. What a weird coincidence. So I want your help with, and it doesn't matter at this point, right? The idea here is though that we want to write something. We can't just Control F to find what we want to write here, right? It just won't work, right? because that social security clause could be any number. It could be instead, it could be 987-65-4321. You know, now social security numbers are of the format of, so the first thing you have to know when you're using regular expression is, what are you trying to match? In this case, it's social security numbers. Social security numbers are always of this format. They're always of the format of number, right? 3 numbers, followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. So it's 9 digits total. Split up into groups of 3, 2, 4, always in that order. Okay. So the idea here is that with regular expressions, you can create, I could just write some, they work first off, just like find and replace at the beginning. I can match the word and by doing AND, and it finds and. If I do AN, it will find these things. Ignore the preceding slashes and the G over here. Those are for a bit more, let's say, legacy purposes than anything else. You won't be using them in your code. What's going to be used here is the part that's bolded. Okay. So how do I match something that is a number? Well, I can put in 1 or 2, but it will match the 1 or the 2, and it's not going to match, anything else. On the other hand, what regular expressions allow you to do is to define character classes. And when I say character classes, I don't mean fighter, wizard, rogue. I mean like character classes as in like different categories of characters. For instance, this says find any lowercase vowel. A, O, brackets, say character set, match anything in the set. A, E, I, O, U. There we go. E, I, O, U. Finds any vowel. If I wanted to find 2 of these, I can just simply copy paste this. So this would look for any 2 vowels in a row, right? In this, there's only this. So for a number, if I wanted to match 3 numbers in a row, I could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, any digit, and look, we're getting somewhere. And then any digit. So it finds 3 digits here, dash, and then it finds 3 digits over here. Now, regular expressions is what it's greedy, as we refer to it in programming terms. It's meaning as soon as it finds a answer, it goes with that answer. It finds the first answer and tries to do that. So 6, 7, 8, it finds that answer, and then it moves on and starts again from 9. So it doesn't count 7, 8, 9 as the second answer. It just simply says 6, 7, 8 is part of your answer, moving on from the end of it, from where I stopped there. Okay. So you can change that behavior, but in general, that's not what in general, greedy is actually what you want. Now, and then if we want to capture the dash after the 3 characters, so we aren't catching this anymore, we would just put a dash afterwards. Okay. Now you imagine that this, if I copy paste this a while, it's going to get rather long and obnoxious. So it turns out that these character sets, that we have some very common ones already programmed in that we can use with escape characters that we learned all the way back in the first lecture, in the first few lectures. So for instance, we can use /W to find any single wordy character. What I mean by that is anything that could be used in a variable name, specifically letters, numbers, and underscores. So wordy characters. Incidentally, so matches any word character. Another one that's super useful is that we can invert it very simply by making it a capital. Capital W matches anything that's not one of those. Very useful. We use /S for white space. So over here, you see it's finding all the space characters, the characters that you don't typically see. That includes things like tabs. And then finally, the one that we care about, /D, which makes total sense for any digit character. Okay, it matches any 0 or 9. And for anything that's not, /d. So we now have enough to write a regular expression that matches this. Yes. They will I think it's for what it's for how it's compiling this. Pretty much every language has a built-in regular expressions library, and they all pretty much work almost the same. There's some with a few extensions, but I'm not teaching those extensions. You're not going to have to know them. I'm teaching the basics of regular expressions because those are useful in every single programming language. And also, I think they're kind of built into like things like Excel as well, like, and possibly Microsoft Word. I feel like you can use those. You can certainly use it in VS Code. You can use the regular if you have in code. Right, we can go over here, and this is going to be hard to see because it's part of the interface, right? If I hit Control F over here, there's these little things over here which says make it case and match the case, match only the word, not parts of the word, and then over here where it says dot and star, that's shorthand for using regular expressions. So you can just click on that, and suddenly you're searching in regular expressions. So now I can find /d. And it finds all the numbers in here in this document. So you can, so again, it's the same language that's being used over here. And that gets me, and it used .star to represent for the symbol for that, which seems really weird, but those are two very specific things to regular expressions. A dot is the wildcard character. And that means that it matches any character. So if you remember back to my wildcat question from the second practice exam, which says find anything that has a C followed by anything followed by a T in regular expressions, that's C dot T. There's nothing in this one that matches that expression there. Now the star is the clean star that I alluded to earlier, which is match at least 0 of, and hence warning because it's matching pretty much everything at this point. I think, yeah, no match, found a bunch of 115 empty matches. So this says at least 0 of the preceding things. So this matched 0 L's as well as 1 L and 2 L. Makes more sense though with the plus operator, where we're saying match at least one of the preceding. So this matches the L's in hello as well as the L's here. You'll get into those later, but moving back to the social security number, we now have enough to refer back to the social security to figure out to write the social security number /d/d/d for the first 3, then a dash /d/d, then dash, and then four of these to do that. And now this will match any social security number, not just this, but let's go ahead and do some other ones that are not hopefully anybody's social security numbers, because that would kind of be terrible. 987654321, right? And let's go ahead and rotate that. 654321987. I think rotating these are fair. It's a fairly safe way to make sure that these are not going to be anybody's particular number. Yes.
How would new line characters be?
A white space. I believe. But there's a way to, I don't normally have to look for new line characters, but I believe it's white space. Regardless, we've got this over here and it matches all of these things without necessarily matching something that's not of that pattern. Right? If we have something that here that is not got the this letter, it's not going to match it. Or if the or if we have the dashes in the wrong places, if we have the dashes in the wrong places, so and group it wrong, it's not going to match that. It is specifically 3 digits followed by a dash, followed by 2 digits, followed by a dash, followed by 4 digits. Make sense? So this also is a bit tedious. It seems silly to have this nice, concise language and not have a way to reduce this further. we do have a way to reduce this further. To make it a bit, we can use something called the quantifier, which I think you'll be able to figure out what that does very quickly. Just by looking at the fact that that it matches the same thing that we did. You're smart, you probably figured this out right away. The quantifier says, hey, the number in curly braces match exactly that many. So match exactly 3 of the preceding. So match 3Ds, match 3 digits, then the dash, then 2 digits, then 4 digits. So here, if we, for instance, if I wanted to go back and match 2 L's and only 2 L's, I can do this instead of writing out LL. Seems like a lot of work, but typically, this is used for doing something a bit more complex. Typically, we use this for doing something like matching like a specific range. So like LOL, like that. So that would be an L followed by an O. And actually, this is actually a challenging one, LOLOL, because it has a, oh no, it's not that challenging because it's going to end with an L. So LOLOL, right, which you've probably written before at some point. You know, it's the letters LO, one after another, repeated for an arbitrary amount of times, then ended with an L. So I can group these things together using parentheses, and it matches that LO, it matches LO as one unit, and it says, hey, LO taken together, I want to match at least one of those. So any number of LOs taken together, followed by an F, and then we end up with an L. So here we can see we have a bunch of LOs, and then when I remove the L, it doesn't match that fully anymore. And over here, now it matches it all because it matches 1, 2, 3, 4, 5 L's followed by, 5 LOs followed by an L. Now, if we want to be more specific, say that we only want something that's reasonable, not somebody's cat accidentally did the copy paste thing, then we can use the quantifier again. So here I want only 1 to 4 I only want an LOL that is only 4 lols long, or at most. So this matches LOL, LOLOL, LOLOLOL. See, so it's matched 1 of these, 2 of these, 3 of these, and then it matches 4 of these. But it doesn't do any more than 5. It doesn't do any more than that because we did LO1, LO2, LO3, LO4. That's the most we're going to match. And then we find that, and then we stop with an L. Hence why it doesn't capture the OL at the end of this. So we can use this to quantify. Easier example. Let's go back to our digits examples. 3 or anywhere between 3 and 4. So this matches 3, 4, it matches groups of 3s, it matches. So this would be any 3-digit or 4-digit number. Make sense? So you can see like how this is really, really useful. Now, how do you use this in Python? I suppose I can talk about that now. And then we can move to concrete examples. Okay. Let's open up idle. Okay. So Python makes it super useful because, of course, there's a library for that, and it's a well-named one. In fact, every thing I know of has a library for regex, if it's a modern programming language. C probably has a library. It just doesn't, I don't even know if it will come pre-installed, but you know, but somebody's written one for C, you can guarantee it. import regex for a regular expression, or regex. I don't care how you pronounce it. It's fine. Import regex. No module named regex. What? Oh, no, it's not import regex. It's import RE. For some reason. Okay, I guess they really wanted to save 5 characters or 3 characters there. It's the RE for regular expressions. Okay, there we go. Now the most common thing you'll be using, there's a lot of different ones over here. For instance, there's like this idea of creating pattern objects, which create match objects, which are useful if you want to like do optimization and stuff, but we also have, this being Python, it has ways that you can skip all that and not have to worry about the optimization. The one that we'll be using most of the time is the re.sub, is this re.sub function, which says taking a pattern, a REPL, a string, and then it's got 2 other optional variables there. Now, sub is short for substitution. Now, a pattern so what is a pattern? Well, a pattern is the regular expression that we are matching. This up here, the regular expression is what's referred to as our pattern. Okay. Now, over here, let's see. REPL is what we want to replace the pattern with. This is substitution. We look for we look for something and replace it with something else. Okay. The string is what the target is. So pattern, what we're looking for, what it's going to be replaced with, and where are we looking for it. So for instance, if I want to replace any digit I see in this with, so let's say I want to replace any digit I want with, well, let's see, let's say the letter X instead. Okay. In this, in some target string. Okay, I don't know. I just made up some nonsense there. Okay, so we've got our target, and we're going to say look for any character, any digit in there, and replace it with X. And it does it. The year was XXXX, and it was cold. Okay, which now that can be any year if they're all cold. So now, how do we combine this into the idea? Yes. If you wanted to search for an actual number, I believe you would probably need to search for, say we only wanted to target 1, the number 19, right? You'd still have to give it a string, I believe, because because we're working with strings here. Okay, but say you want to target specifically 19. Michelle. Wish there was a way to scroll down. Sorry to not have this at the bottom, but oh well. So let's go ahead and import RE. So let's say we want to just replace the number 19, or sorry, the number 27 with that. We could. The year, or that just replaces 27 with X. So I could change that up and do and that takes any number and replaces it with 2 X's. All right. But now say you want to let's see if I can remember how to do this. Okay. Let's say we want to, we want to do it like the year was 2027, but we want to take out we only want to take out the last 2 digits of it. Let's see, does that allow me to do that still? Let's see. No, it was. Oh, okay. If I'm hold on, I'm trying to work from memory for something I haven't done in like 5 years. So give me a second. 20. And then let's do /1, I believe is the term. Nope. Don't remember how to do it. I can look it up though very quickly. So our book, so in our text, sorry, in our syllabus, your textbook doesn't really go over this part, any of this stuff. But I do have another textbook listed in my syllabus that I've used for this class before, and I use many times. It's listed in syllabus as an alternate resource called Automate the Boring Stuff with Python. It's targeted towards basically anybody who wants to take this class and never take any programming again, essentially, is the idea. It teaches, and you can tell by its very interesting curriculum, but I love it because it's really practical. It's got, okay, the standard stuff we'd be learning over here, but notice that over here he throws in regular expressions in chapter 7. And then over here we have things like web scraping. How do you read information off the internet? How do you work with Excel spreadsheets? Not CSVs, Excel spreadsheets. Working with Google spreadsheets, PDFs and Word documents. Keeping time, scheduling tasks, launching programs, controlling the keyboard and mouse, manipulating images, all those kinds of nifty things. So with regular expressions, first off, there's going to be a lot of RoboCop examples because that's what he does. Also bat, but let's see. Ari.sub, does he do Ari.sub? No, he just uses sub, using the sub method. So over here, yes, you can use, interesting that, oh, you have to use raw strings. Okay. So we just simply did it a different way. That's right. Okay. So one word of exclamation I should put here is that you can look up this thing and you notice that there's an R in front of the string he put in here. That is the thing, I think the last thing I'll probably tackle today. So there's different ways of representing strings in Python. There's the normal way we do it, which is, hello, this is a string /n with a, and then let's see, with a new line in it. And let me go ahead and copy it because I'm going to need to use this. Let's see, and didn't go. Interesting. Did it not want to? Oh, right. Because, right, it's not going to do that. It's going to keep the raw string. So X is equal to this. Print X. And now when we render it, there we go. Hello, this is a string with a new line in it. Okay. And now with regards to what is a raw string? Okay. A raw string is this. Let's go ahead and grab this again. But now I'm going to put the letter R in front of it. And we really only use this in terms of regular expressions. And this has to do with the way that Python is being super smart here, where it's escaping the escape characters for you, I believe, automatically. But regardless, here's what R does. Okay. Hello, this is a string with a /n. Sorry, this is a string /n with a new line in it. R just simply takes things as it's been presented to it, and ignores like all the escape characters or any special stuff that you put in there. So that can be useful sometimes for when we deal with regular expressions. Let's see if that worked here. Did that work here? Yes, it does. Because Python sometimes gets really does something interesting about with regular expressions that other languages don't. In Java, if I had to write this, in Java, if I had to write this regular expression /d, which means any number, I'd have to do something really annoying. I'd have to do that. So replace any digit with, and it's the same thing, replace any digit with X, and notice it still works. This is an instance of Python being really smart for us, where it says, aha, this is a regular expression. So you probably aren't trying to use an escape character. So let me escape the escape character for you. Right? The idea here is that in your typical string, right, the / operator indicates to anything that's parsing the string, hold up, there's a special character coming that you normally can't type. Okay. And if you want an actual /, you need to have 2 backslashes. So Python's kind of being smart here and automatically figuring it out for us, but that impacted us here. So if we wanted to do, so it thought we actually meant /1, which is its own special character over here, rather than thinking, oh, you want /1. So hence the R. So if I didn't want to use the R though, the raw string, I'd do /x. This is /1. You almost never have to worry about this with Python. In fact, don't really worry about it. This was a very niche case that I hit upon. But this is actually very common for programming languages, that you'd have to escape your escape characters. If you want to be extra careful with this, just put an R for raw string or an R for regular expressions in front of your strings. There is another way you can do that with Java does have another, Python does have another thing it does, which is binary, I believe. Binary strings, which are preceded with a B, which says, what is the binary representation of that? Let's go ahead and actually see what this is. Does it print that out, or no? It just simply says. Look it up if you want to go into it. It is weird. Python's pretty cool, and it has these really interesting abilities. But again, regular expressions is a feature that's built into every single language that you can use. They're extremely powerful tools, and it's a shame they don't get taught earlier, because again, the course where they naturally come up deals with weird flowcharts and stuff. And yeah, sometimes you get into other weird stuff like this is a valid regular expression, the plus or minus symbol, optionally a plus or minus symbol, followed by a digit, any number of digits, and a decimal place, and then at least 0 digits there, or no preceding digit. So you can read these once you get one, like I'm doing right now, once you get the hang of it. But the idea here is that unfortunately they can get very complicated, but a lot of times they don't really need to be. I'll leave this for you to chew on. And this is what I mean by they can get really complicated. Email regex. This is unnecessarily, this is the, let's see. Oh, really? Is it not on here anymore? Right, email regex, 99%. So the regular expression that 99, let's see, this will probably link to it. Emailregex.com. Okay. Oh, okay. That's why it's no longer working. It was a ridiculously long regular expression. Oh yes, there it is. that works according to the the RFC official standard for email addresses. A lot of times, you sometimes email, regular expressions are horrifying, like this awful monstrosity. But they don't have to be. A lot of times we're using them for very simple tasks like what we were doing here. Don't let this kind of stuff dissuade you from learning regular expressions. I'm not going to be doing anything of this magnitude anywhere near in the same neighborhood as this monstrosity of this. Okay. But they are so useful for doing those simple tasks of just simply removing something or finding relevant pieces of information in a specific format. Now, I will end the lecture here. Now, for those of you who did not meet with me on last Thursday, if you're here in class, please come speak to me right now. So if you did not give me your proposal or you did not get approval from your proposal, just come up and speak to me right now. That way we don't have to secure another